Digital twins for PET calculation is a tool that allows you to calculate the physiological equivalent temperature, a metric that takes into account not just the ambient temperature, but also factors like shadows, humidity, wind speed, and solar radiation. This analysis enables you to understand the real impact of these environmental variables on human comfort and well-being. With digital twins for PET calculation, you have the freedom to design trees, buildings, and parks. It provides an interactive platform that allows urban planners, architects, and environmental enthusiasts to explore, analyze, and create sustainable urban environments. Now let me show you how our web app tool works. As soon as you open the tool, you'll be greeted with an informative splash screen that provides insights into the project. Please take a moment to read the vision behind this tool. Once you're ready, simply click OK for the splash screen to disappear. The main window is divided into 3 sections: the main map, the editing tools, and the geoprocessing window. Let's start with the main map. Here, you can navigate through the city, observing its current state and identifying areas that require attention. Explore and familiarize with the navigability of the map. Once you've chosen a specific area where you'd like to calculate the physiological equivalent temperature, PET, we're ready to make some changes. Now, observe the editing tools, located in the top right corner. By activating the desired editing capacity, whether it's creating buildings, trees, green areas, or water bodies, you have the ability to mold the urban environment. Let's begin by creating a building. Simply click on Building and draw the structure anywhere you desire on the map. Be aware of existing buildings and trees, and double-click to finalize your creation. A convenient pop-up window will appear, requesting the height of your newly created building. Enter this value, as it will impact factors such as shadows and wind patterns. For green areas and water bodies, the process is similar, but without the need to fill out additional information in the pop-up window. Now let's add some trees. Click on New Tree. Choose the desired location, and with a simple click, the tree will be created. Repeat this process to add more trees. Click on New Tree, locate your mouse in the desired location, and click again. You can also visualize the editing you just made in a 3D environment by going to the link below. With your study area defined, it's time to move on to the geoprocessing window. Here, you can select each layer and assign the corresponding title, or introduce new layers to the map, enriching your analysis with alternative data sources. At the bottom of the geoprocessing window, you'll find fields to input data such as the date and time of the year, the temperature you want to analyze, radiation received, and relative humidity. These values can be sourced from your local weather station or your weather app. By default, we provide data for the hottest day in the past 5 years, specifically July 25, 2019, with a record-breaking temperature of 40.2 degrees Celsius. Once all the necessary information is filled in, simply click Run and let the tool process. It will take some minutes for the tool to generate a finished geoprocessing result, ready to be downloaded and visualized in your GIS software. With a simple drag-and-drop action, the file you just downloaded can be visualized. Initially displayed in black and white, we can enhance the visualization to ensure readability and analysis. By applying new symbology and adding visualization effects, we transform the raw data into more understandable visualization. It's at this stage that we can truly comprehend the impact of our design choices and compare scenarios side by side. Now it's your time to explore and push the boundaries. What if the global temperature rises by 2 degrees? How about 4 degrees? Use Digital Twin for PET calculation to simulate different scenarios, analyze their implications. If you have any questions or require further guidance, our team can support you every step of the way. This project is a collaboration between ITC Faculty of Geoinformation Science and Earth Observation at University of Twente and Vrije Universiteit Amsterdam for the Twinning for Climate Resilient Urban Solutions project.